Hey guys, welcome back to the channel. So in this video, we would be solving this pretty interesting problem. So this is asked in many of the tech interviews. So let's go through the problem statement. So basically the problem is product of the array except self. So you can go through the problem statement, but what it basically says is we are given an array of integers and we have to return a result array where each element in the result array will represent the product of the elements throughout the array except including that element. Like if we are given an array 1 2 3 4, so what we have to do is we have to return the resultant array where for the first position we will exclude the first element and calculate the product of all the elements, which is 4 3 is 12, 12 2 is 24, which is 24. For the second element we will exclude this second element and calculate the product of remaining elements, which would be 4 3 is 12, 12 into 1 is 12, which is 12. Great. So this is what we have to return. So first things first, let's try to make some observations here. So let's consider this first test case. So I'll just write it quickly in Excel. Okay, so I'll just paste it. Okay, so the first observation which comes to our mind is we know that we don't have to include a particular element and we have to include all the elements, like all the other elements. So for this place, like for 0th index, let's say we calculated the product as 1 into 2 into 3 into 4, and then somehow we have to remove this one. So let's say we divide it by 1. In this way 1 will be removed and we will get the product of remaining elements. Okay, so this makes sense. So here we got 24. Okay, let's try for the second element. For the second element, again we have 1 into 2 into 3 into 4, and we divide by the second element so that this 2 and this 2 will be cancelled, and again we get the remaining elements product, which is 12. Okay, so this seems to be working, but wait, let's check another test case. Now let's pick this test case. Okay, so if we proceed with the same plan, then again for this place we will get the product as -1 into 1 into 0 into -3 into 3. Now if we divide by -1, then -1 and -1 will be cancelled and the remaining product would be 1 into 0. And now as 0 is present here, if you multiply it by anything it would still be 0. Okay, so I'll just write the result here. So it is 0. Again for this first element, let's say we have -1 into 1 into 0 into -3 into 3. Now again if we divide by 1, we'll just cancel this one and the remaining part is again 0 because we have 0 in the product. Okay, so again here 0. Now when we have this 0, okay, let's say we consider 0 here now for this second index. So what is the answer here? Now we cancel 0 and 0, but actually we cannot remove 0 from here, right? Because we already have this product which is calculated as 0 into anything which is 0. So we cannot remove this 0. But what if we have not included this 0? Then the answer would be -1 into 1, which is 1, into -3 into 3, which is 9. So the answer would be 9. But according to our logic, we cannot do this, right? Because as 0 was there, the product was 0. Okay, so this does not seems to be working. So what we can do? Let's erase this first. Okay, so now for each of the element, we know that we have to exclude this element and we have to find the product of the remaining elements. Okay. Now for this first index, I would exclude this first index and calculate the product of all the remaining elements. Okay. Similarly, for the second element, we will calculate the product of the remaining elements. Okay. So the pattern that we can say is, for a particular element, we get the product of all the elements before this element and the product of all the elements after this element, right? So whenever we have this kind of problems where for each of the element we want some operation from all the elements before this element or all the elements after this element, we use the concept of prefix sum. So in prefix sum, what we do is, for each of the element we calculate some of the operation for all the elements before this element. Okay, so here the operation would be multiplication operation, which is the product operation. So we will calculate the product of all the elements before the particular element. Similarly, for this element, we will again calculate the product of all the elements before this element. Okay, now we know that we also want the product of the elements after this particular element, right? No issues, we will calculate it in the same way as we calculate prefix sum. Okay, so this will be the suffix part. I would say the suffix sum, or more clearly the suffix product in our case, and prefix product. So for each element we will calculate the product before this element and after this element. So let's go to the code. Okay, so let's write the code for it. So first let's define the length of the array. Now let's maintain two arrays. First one is the prefix array, and the second one is the suffix array for storing the suffix product. Okay, so this would be new integer of size n. Let's make it long because we are calculating product and it may go above the value of integer. Okay, now we know that from constraints the length of the array would be minimum 2. So in any condition we would always have one element in this array. So we will store the first element, which is the 0th element, and it would be simply the 0th element of the array. Similarly, we will store the last element and it would be the last element from the array. So what I'm actually doing here is, let's say I have some array as 1, 2, 4 and 3. Then I'm storing the first element as it is in my prefix array. Let's say this is the prefix array. And for the second element, I'll calculate the answer of this second element by using this first element. How? So simply I'll just multiply the value of my current element with the previous element, which would be 2 into 1, which is 2. Similarly, for the next element, I'll again multiply the value of my current element with the previous element, which would be 4 to the 8. So we got a product of this part, right? Which is 4 to the 8, which is 8. Great. Similarly, for this last element, we'll again multiply 3 with the value of the previous element. So 8 3s are 24. So we got our prefix array, right? So let's do the same thing. So I'll start from the first index because for the 0th index we have already filled the values, and we'll go to the very last element, and what we'll do is we will calculate the prefix part as prefix of I minus 1, which is this last element prefix, into my current element. Similarly, we will calculate the suffix array, and here we will start from the second last element because for the last element we already have calculated the values. So I'll go till 0, and what I'll say is the suffix element is equal to the suffix element of this next element into array of my current element. Okay, So let's make it clear. So basically we have 1 2 4 and 3. For the suffix part, we are calculating it from last. So first we stored 3, then we started from here, and for this 4 we again did the same thing, which is 4 into 3, which is 12, then again 2 into 12, which is 24, now again 24 into 1, which is 1. Okay, so let's move to the next part. So we have calculated our arrays, right? Now we'll just maintain the result array in order to return this, and it would be of length n, and just we'll go to every element. So here let's maintain a variable product. Now it would be initialized with 1. Now we want the product of the left part and the right part. Okay, so I know that the left part exists if the current index is greater than 0, right? So if basically the index is greater than 0, we know that the left part exists. Okay, so we want the product of the left part, which is product into prefix of this left part, right? Similarly, we know that the right part exists if the current element is less than the last element, right? So if the current element is less than the last element, then we know that the product exists. So the product would be product into suffix of this next part, right? Then at last we got the product of this complete left part and right part. So we'll just store this in our result array. So at last we'll just return this. Great. So let's try to run this. Okay, so it is getting accepted. So let's try to submit this. Okay, so it gets submitted. So thanks for watching and subscribe to the channel for more such videos.